Hi, I am Saif, and we are presenting our paper called EvolveUI, User Interfaces that Evolve with Users' Proficiency. This work was done in collaboration with Taha, Zakir, and Agha Raza from LUMS and Mustafa Naseem from the University of Michigan. Let me tell you a little secret. I am only 15, still in grade 10 and still in school. And not only am I the youngest author in Campus this year, I am also the go-to tech support guy for my grandmother. Most of the time, I get called in to find the button that sends a voice message or to find that lost image that she couldn't find on Facebook. But the biggest problem she faced was trying to understand a new application. Even WhatsApp, for example, has a plethora of complex menus and options, which are incredibly hard for someone like her to even understand. I noticed that she'd just give up and couldn't even grasp the core functionality of such apps. Of course, this is not very dissimilar to users who have not used technology at all, either due to low literacy, affordability, or access. This is very common in developing countries like Pakistan. While working with my grandmother, I often wondered if I could simply reduce the app to just one button, which would allow her to use the core functionality of the app itself. But as she learned how to use that button, the app would systematically introduce more complex features. That approach led us to EvolveUI, which starts with a single node or a single navigation point and gradually and systematically evolves according to the user's proficiency.
However, such adaptive interfaces have been tried before with mixed results. A wealth of prior research warns us about the cognitive overload faced by users due to the constant changes in the UI. Therefore, our proposal is not as much to adapt the interface, but to gently evolve it as per the user's proficiency. An application implemented by EvolveUI aims to minimize the cognitive overload typically faced by novice users. Once a UI evolves, it is no longer reorganized or further adapted to avoid confusion for our users. To validate our approach, we implemented a mobile health application using EvolveUI and evaluated it using a small-scale user study. We designed two versions of the application, a conventional design that presents all features upfront and an EvolveUI variant that introduces features gradually. We conducted usability tests with 36 participants from rural Pakistan, most of whom had no prior experience with smartphone applications. Participants were divided into two groups, each testing one version of the application by completing a list of tasks relating to the application's functionality, such as recording a question or listening to community stories. We measured key metrics, such as task completion times and system usability scale or SUS scores. The mean SUS scores of both groups were comparable and fell into an acceptable usability category, despite the user's limited experience with smartphones. Interestingly, we observed that users with some modicum of education, who had at least completed middle school, found the EvolveUI application 30 to 40% more usable than the conventional design. Thus, for semi-literate users from rural backgrounds, EvolveUI seems to be a very compelling approach. By offering a gentler learning curve and reduced cognitive overload for first-time application users, we aim to make smartphone applications more accessible and engaging for users with limited literacy.
In the future, we are planning to build more complex applications using EvolveUI and performing a more rigorous evaluation of our approach using larger user groups, and hopefully replace myself with EvolveUI for my grandmother.